In the last video, we talked about substitution to solve a system of equations. In math speak, we're solving simultaneously a system of linear equations, and we solved them with two variables by way of substitution. In this video, I just wanted to look at three variable equations and then maybe something else. So suppose we have x plus 2y plus z equals 10, 3x minus 4y minus 2z equals 5, and 2x plus 3y minus 4z equals 8. And hopefully this will have a solution. And again, in practice, the method is the exact same. Solve for a variable, plug it into the second equation, solve for a variable, plug it into the third equation, solve for a variable, and then backwards substitute. You just have to do the same thing multiple times. We said last video, as far as it goes, it is best to pick, if you're going to use substitution. It will work in all instances, but substitution works best if you start with a variable that has a coefficient of 1. So in this case, and I'm going to try to use different colors to color code this. Here, x has a coefficient of 1, so I'm going to start by solving for x here. So I just subtract the other two things. I get x equals 10 minus 2y minus z. So there's my x. Now I'm just going to go down the columns here. Substitute x in there. And we'll switch up colors. We get 3 times x, which is 10 minus 2y minus z, minus 4y minus 2z equals 5. If I distribute, I get 30 minus 6y minus 3z minus 4y minus 2z equals 5. And here again, this is, bear with me, my iPad just froze. Okay, but it should be good. Okay. This is an equation with two variables. So I just pick one variable and solve for it. And again, since I solved for x in the first one, I'm just going to solve for y here. If I solve for y, minus 6y minus 4y is negative 10y. Let's see. Negative 3z minus 2z is negative 5z. Add it to the other side, so that's 5z. 5 minus 30 is negative 25. Then I divide the negative 10. Y is equal to 5 divided by negative 10, that's negative 1/2 z. Negative 25 divided by negative 10 is positive 5/2. Now I have y. Now I'm going to go to the third equation and substitute in and solve for z. And keep in mind, this equation has an x, so I'm going to have to substitute my x in. It has a y, so I'm going to have to substitute my y in. And the x that I substitute in has a y in it, so I'm also going to have to substitute the y in there. Because ultimately I need one equation with one variable, z. So I have to get rid of all the other variables. So if I write it out, that's 2 times x, which is 10 minus 2y minus z, plus 3 times y, which is negative 1/2 z, plus 5/2, minus 4z equals 8. But now, again, I have the negative 2y here, so I'm going to plug y in there, and I get negative 2 times y, which is negative 1/2 z, plus 5/2, minus z. And then it should be plus 3 times y, and good. Now just do all the algebra and simplify this out. And we know with parentheses, start on the inside and work your way out. So it's 2, 10, negative 2 times negative 1/2 is positive 1, z. Negative 2 times positive 5/2 is negative 5, minus z. 3 times negative 1/2 is negative 3/2 z. 3 times 5/2 is 15/2, minus 4z equals 8. Distribute again. 2 times 10 is 20, plus 2 times z is 2z. 2 times negative 5 is negative 10. 2 times negative z is negative 2z. Negative 3/2 z, plus 15/2, minus 4z equals 8. And now I'll point out, you can solve this with the fractions in there. If you want to, you can. All things being equal, I think students aren't the biggest fans of fractions. So I'm going to multiply everything by 2 to clear the fractions out. And I get 40 plus 4z minus 20 minus 4z minus 3z, here the 2's cancel, plus 15, again the 2's cancel, minus 8z equals 16. Now just combine the z's, constants. 4z minus 4z is 0. Negative 3z minus 8z is negative 11z equals, let's see, 40 minus 20 is 20. 20 plus 15 is 35. Subtract it over, you get 16 minus 35, which is negative 19. Divide the negative 11, you get z equals negative 19 over negative 11, which is 19 over 11. Now, take that z, stick it in here and get y. Y is equal to negative 1/2 times 19 over 11 plus 5/2. That's negative 19 over 22 plus 5/2. Here again, to make it easier, multiply everything by 22. You get 22y equals negative 19 plus, if I multiply this by 22, 22 over 2 is 11 times 5, 55. So 22y is 55 minus 19, which is 36, and then divide the 22. Y is 36 over 22, which is 18 over 11. And yes, I'm aware we end up with these complex fractions. It's part of the deal. Now I have z and y, plug them in there to get x. And here, this is the video, so you can save it and all that. So I'm going to have to erase this. And I get x is equal to 10 minus 2 times y, which is 18 over 11, minus z, which is 19 over 11. So that's 10 minus 2 times 18 is 36 elevenths, minus 19 elevenths. 10 is just 10 times 11, that's 110 over 11, minus 36 minus 19. 36 and 19 is 55, 110 minus 55 is 55. So we get 55 over 11, which is 5. And apparently x is a nice number. Sorry, that's wrong, correct? No, that's right. Good, because I'm subtracting, not adding. Whatever. Okay, good. So now I have my solution. X is 5, y is 18 over 11, z is 19 over 11. I'm not actually going to go through another one of these because, again, they take a really long time to get through. The algebra is the same. It just takes longer because there's more of it to do. And now let me check the length of this video. It is 8 minutes. Okay. So one more thing we want to do, another trick. This is called substitution. There is also a trick called elimination. And this is actually in 8.2, I do believe. We used to call this matrix row reduction. It's the same thing. People who are going to end up in linear algebra, you'll do matrix row reduction, but it's the same principle. The idea, suppose I have 2x plus y equals 8 and 3x minus y equals 4. One thing I can do, substitution, pick a variable, say y. Solve for y, so subtract the 2x, plug it in that down bottom, solve for x, backward substitute, do all of that. But another trick I can use is what's called elimination. And again, from an efficiency standpoint, if you have two variables that have identical coefficients that are either the same or opposite in sign, then elimination works well. In this case, that's a positive y, that's a negative y. They're the same, they're just opposite in sign, plus and minus 1. So, what I do for elimination is, I combine the two equations together. Add them. 2x plus 3x is 5x. Y minus y is 0, so it disappears. 8 plus 4 is 12. And now I can immediately solve for x. X is 12 over 5. Now I just pick an equation. I'll go with the first one. I substitute the x in and I solve for y. 2 times 12, that's 24 over 5 plus y equals 8. So y equals 8, which is 40 over 5, minus 24 over 5. 40 minus 24 is 16 over 5. And I get a solution just like that. So if I have a system of equations where the variables have the same coefficients, either the same or opposite in sign, elimination works well. You eliminate a variable really quickly, and then you immediately get one solution, which then immediately lets you substitute and get the other solution. Really quickly, because we can expand on this, all the algebra that we know we can use. So suppose I have 2x plus y equals 7, x plus y equals 4. Well, I want to solve this. Here, the variables, they have the same coefficient, but they're not the same in sign. I'm sorry, they are the same in sign, they're not different in sign. So what can I do? Well, in this case, I'm going to take the bottom equation, and from a matrix reduction perspective, if you do linear algebra, that's what we'll call it, row reduction, you multiply by a constant, in this case, -1. Now your system becomes 2x plus y equals 7. If I multiply this by -1, I get -x minus y equals 4. Now, I can just combine these like I did in the last one. 2x minus x is x, y minus y is 0, 7 plus 4 is 11. I didn't put the negative there. Okay, I knew I messed up. When I multiply the -1, -1 times 4 is -4. This should have been 3. 7 minus 4 is 3. Now I get my x. Pick an equation, I'll use the second one. 3 plus y equals 4. Subtract the 3, y equals 1. And I get my solution immediately. But you can expand on this. Suppose you have the equations 2x plus 3y equals 5, 3x minus 4y equals 8. Now, if I think about it from a substitution perspective, I can use any substitution I want, but none of the variables has a coefficient of 1, so I'm going to have to do more algebra, and there'll be division involved and fractions, which maybe I don't want. But from an elimination perspective, none of the variables have coefficients that are the same. But I can use my idea from the last one of multiplying by -1, multiply by whatever I want. In this case, I'm going to pick a variable. I'm going to pick the y, because they're different in sign. Now I'm going to find their LCM, their least common multiple. What number do 3 and 4 both go into? 12. So, I'm going to multiply the top equation by 4, because 4 times 3y is 12y. I'm going to multiply the bottom equation by 3. 3 times -4y is -12y. Then I can combine them. So I rewrite my equations. 4 times 2x is 8x, plus 4 times 3y is 12y, equals 4 times 5, 20. 3 times 3x is 9x, 3 times -4y is -12y, 3 times 8 is 24. I combine. 9x and 8x is 17x, 12y minus 12y is 0, 20 plus 24 is 44. So x is 44 over 17. Now I pick an equation. I'll just go with the first one. 2 times x, which is 44 over 17, plus 3y equals 5. So that's 88 over 17 plus 3y equals 5. 3y equals 5, which times 17, that's 85 over 17, minus 88 over 17. So 3y equals 85 minus 88 is -3 over 17. And then just divide the 3. So y is equal to -3 over 3 times 17. The 3's cancel, and I get -1 over 17. and I get my solution. And the point here is, just like with substitution, both tricks will always work. There are certain times when one is more efficient. If you have a variable with a coefficient of 1, substitution works well. If you have both the variable in both equations having the same coefficient, same sign or different, elimination works well. But you can solve any system with substitution or elimination. Sometimes the work just takes longer. If you need more examples going through these, let me know and I'll make more videos. It just takes a while to write them out, so I can't get a lot of examples in to a given video. But if more examples will help, just let me know. That's not a problem.